Hello again, grade 8s. In today's lesson, we're going to continue to look at graphs of linear relations, albeit this time around, we're going to look at variables that actually have physical meaning. In the previous lesson, we were constructing our graphs. We were just using the variables x and y, which are just generic math variables that actually don't have any physical meaning. But in science, for example, we look at many different types of experiments where we have like manipulated or responding variables that do have physical meaning, like for example, heating time or distance traveled or angle something is thrown at. So it's a little bit more complicated to actually construct graphs if we do have physical meaning for these variables. And that's what I'm going to show you how to do in this lesson. Okay, so this is going to be a little bit of a review of some stuff you'd have learned back in grade 7, but we're going to make it a bit more complicated in terms of the scaling of the graph this time around. Okay, so I said a completely labeled and appropriately scaled graph can be constructed by following the steps in example 1. Okay, so let's read example 1. A car drives with a cruise control speed of 110 kilometers per hour. This relationship can be expressed by the formula or the equation D is equal to 110t, where t is the driving time in hours and d is the distance traveled in meters. So you'll notice right away we're not using the generic x and y variables. We're using the variables t and d, which have physical meaning. T is driving time, d is distance traveled. Okay, so we first of all want to start off by constructing a table of values for values of t that are going to be 0, 1, 2, 3, 4, and 5. Okay, so let's do this. So we're going to use the equation to complete the table of values. So here's my table of values. So I have time value of 0 all the way through 5. And we're going to use that equation, just like we did in the previous lesson, to determine what the value of the distance d is going to be. So instead of calculating y, we're going to calculate d. Okay, so here's what my equation would look like. So d is equal to 110, and then if it's right beside the t, it's implied that it's multiplication. So we're going to start off by taking t equals 0, and then we're just going to sub it directly into that equation. So instead of writing t, I'd have 110 times 0, which would just be 0. Okay, it was just pretty obvious. If you've driven for 0 minutes, you haven't gone anywhere. Your distance traveled would be 0. Okay, so your ordered pair would be 0, 0. When t is equal to 1, again, we'll take that 1 and we'll plug it into the equation for the value of t. So that'd be d is equal to 110 multiplied by 1. And that would give me a d value that's equal to 110. Put it into the table of values. So you have 110 would be the distance, and then the ordered pair would be 1, 110. For a time value of 2, plug it into the equation. So you'd have d is equal to 110 multiplied by 2. 2 times 110 would be 220. So the distance traveled would be 220 meters. I just realized that meters actually doesn't make a whole lot of sense here. This really should be kilometers. Okay, so let's change the unit of measurement. Okay, let's go back here and see if we actually can fix that on there. Yeah, let's change that to kilometers. Okay. Where are we at here? I think we were at t equals 2. Okay, so 110 times 2 would be 220. Then you'd have 220 kilometers. And my ordered pair would be 2, 220. And then you have when time is 3, plug it into the equation. 110 times 3 would be 330. So you have 330 as your kilometers now, as your distance traveled. Okay, that makes a lot more sense. And then your ordered pair would be 3, 330. When your time traveled is 4 hours, you'd have d is equal to 110 multiplied by 4. So d would be 440. Therefore, you'd have 440 is the value of d. The ordered pair is 4, 440. And the final value, plug in a value of t equals 5. So that'd be d is equal to 110 multiplied by 5. 5 times 110 would be 550 kilometers. And then your ordered pair would be 5, 550. Okay, so that's step one. We use the equation that's given to actually complete a table of values, and now we have data that we can actually plot. Okay, now, before we even plot the data, we actually need to, on the graph, write a bunch of titles for 3 different parts of the graph. We're gonna write a title that goes above the graph, we're gonna write a title for the x-axis, and we're gonna write a title for the y-axis. Now, when you write a title for the axis, it should go in the following form. So the way we would write this is we first of all write out the name of the variable. So for example, if the variable is t, the name of the variable will be time. Then we write a comma. Then we write down the letter used to represent the variable. So we're talking about time, the letter would be t. And then in brackets, we identify the unit of measurement. Okay, let's quickly correct this table again. Again, this would be kilometers for this to make any sense at all. Otherwise, it's the slowest moving car in human existence. Okay, so now let's start to actually write these titles. So just a generic title above the graph, I can just call it cruise control because it's a vehicle that's moving on cruise control. There's various titles you can write as long as it's just relevant to the context of the problem. Okay, now the titles for the X and Y axis, if you actually look at the data table, I put it in that exact format we need, okay? So it says write down the name of the variable, okay, that's time, then a comma, then the letter for the variable, which is t, and then in brackets, the units would be hours. So on the x-axis, we can label this as time, comma, t, brackets, second. So again, name of the variable, then a comma, then the symbol used to represent the variable or the letter, and then in brackets, the units. And that should not be seconds, that should be hours here. Okay, let's fix that. It should be time and hours. Okay, then let's do the same thing for the y-axis. So for the y-axis, it's distance. And again, the units right here should be kilometers. Okay, kilometers. So we have time, comma, t, units are hours, distance, comma, d, the units are going to be kilometers. Okay, now we need to scale the graph correctly. So again, let's just fix this here. Hours, kilometers. Okay, now there's different ways to create a scale. Like sometimes you can just look at the data in the table and you can kind of just like be like, okay, I know what the I know like how to scale those so I can fit all the data on it. I'm gonna give you a bit more of an exact procedure as to how to do this, like how to scale a graph properly. Okay, so what I wanna do is I wanna take the largest X and Y values and I wanna divide by the number of squares on each axis. Okay, so if we look at this data table, again, this is kilometers. Okay, this is your X variable, this is your Y variable. So to create a scale, I want to take the biggest X variable and I want to divide by the number of squares on that axis. Well, if you look here, how many squares are on the X axis? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I intentionally gave a grid that is 10 by 10 just because it's very easy to use. And then what we want to do is we don't want to label every single grid line because the points can get very, the labeling can get very clustered. Every second grid line is pretty good in terms of like labeling it. Like you don't want to label only like 3 grid lines, that would be insufficient. Okay, every 2 grid lines is kind of like what a good graph would actually look like. Okay, so let's calculate this, the actual scaling on the x-axis. So what we do is you take the largest X value. The largest X value is 5, okay? Take that number and divide by the number of squares on each axis. Okay, how many squares are on the X-axis? 10. Okay, what's 5 divided by 10? It'd be 0.5. Now, what that would mean is that every grid line would go up by 0.5. So if this was 0, it'd be like 0.51, 1.52, 2.53, 3.54, 4.55. But I don't want to label every single grid line. So what I'm going to do is I'm going to take this number and I'm just going to double it. So multiply by 2, and that's going to tell me how much every second grid line is going to go up by. Okay, so every second grid line we're only going to label, and every second grid line is going to go up by a 1. So here it'd be 0, 1, 2, 3, 4, and then 5. Okay. Now the Y scale, we want to take the largest Y value, so that's 550. Oops. 550. And then we want to divide by the number of squares on that axis. There's also 10 squares on the y-axis. So 550 divided by 10 would be 55. So what that means is every single grid line would go up by 55. So it'd be like 55, 110, 165, 220, etc. But again, we don't want to label every single grid line. So we're going to change it so that we have 55, we're going to double it. Okay, so doubling it is going to be the value that every second grid line goes up by. So I have 55 times 2, which would be 110. Therefore, every second grid line goes up by 110. So it'd be 110, 220, 330, 440, and then 550. Okay, so that's a really nice scale. That's going to fit all of my data points onto that scale. Okay, step 4. We want to plot the data on the graph. Okay, so again, let's make my quick little corrections here. Okay, kilometers. Again, this would also be kilometers. And again, this time here would be hours. Okay, now we're just going to plot these ordered pairs onto the grid. Okay, so we have 0, 0 would be at the origin. 1, 110 would mean go right by 1 and then up by 110. So it'd be located there. 2, 220 would be go right by 2, up by 220, which is located here. 3, 330 we go to the right by 3 and then up by 330, located there. 4, 40 go to the right by 4, up by 440. And then we have the last one, which would be 5, 550 go to the right by 5, up by 550, and then we're good. And number 5 is if the pattern made by the points is a linear relation, then let's go ahead and draw a line through that data and make sure it spans the graphing area. Okay, so my line would just be a straight line that just goes nicely through the data points. Okay, fits very, very, very well. Okay, that would be a nicely constructed linear graph. So again, like you got everything labeled, you have like a nice scale on the X and Y axis. You have titles above the graph, you have titles for the X and the Y axis, and then you plot the points. And then if it's a linear relation, we can put a line through those data points. Okay, let's do one more. Does a person rents a lawnmower by making a $20 deposit and then by paying $8 per hour? The relationship can be expressed by the formula C is equal to 8T plus 20, where T is the rental time in hours and C is the cost of the rental in dollars. So part A, I want to create a table of values for values of T equal to 0, 2, 4, 6, 8, and 10. Okay, so let's go ahead and do this. So what I'm going to do is I'm going to take this equation, C is equal to 8T plus 20, and I'm going to evaluate this for different values of T. So we're just going to do a substitution of different values of T to calculate what the cost should be. Okay, so let's start off with if T is equal to 0, then the cost would be equal to 8 multiplied by 0 plus 20. 8 times 0 is 0, plus 20 would give me, your cost would be equal to 20. Okay, that makes sense because it says that you have to put a $20 deposit down before you even start driving the thing. So at time of 0, or driving the thing, pushing the lawnmower, the cost is already just the deposit. Okay, so this would be 0, 20. Okay, then we're going to evaluate it for T equals 2. So plug it into the equation. So we have cost would be equal to 8. Replace T with 2 now. Again, we'll put it in brackets. And those brackets, once again, mean we're doing multiplication. So 8 times 2 would be 16, plus 20 And then this would be equal to 16 plus 20 would be 36. So we have 36 here. And then this would be the ordered pair, 2, comma, 36. Okay, then we have t equals 4. So the cost would then be 8 multiplied by 4 plus 20. So this would be equal to 8 times 4 is 32 plus 20 would be equal to 32 plus 20 is going to be 52. Because the cost is 52. So you'd have 4 comma 52. And then the next point, we're going to plug in t equals 6. So the cost would be equal to 8 multiplied by 6 plus 20. So that would be 8 times 6 is 48 plus 20 would be equal to 48 plus 20 is 68. So this point would be 6 comma 68. Okay, and then t equals 8. Now, if you actually look at the table, you should be able to see a pattern that's starting to emerge. So at this point, you probably don't really need to continue to use the equation to fill the rest of the table in. But I'll just do it just for the purpose of like evaluating and getting practice with the equation. Okay, so t is 8. So we're going to replace t with 8. So we're going to have 8 multiplied by 8 plus 20. 8 times 8 is 64 plus 20 would be equal to 84. So I've got 84 here. And then I have 8 comma 84. And the final point would be 10. So we're going to replace up here t with 10. Replace it in brackets with 8 times 10 plus 20 would be equal to 8 times 10 is 80 plus 20 would be equal to 100. Okay, so this final point is 100. So we're going to have 10 comma 100. Okay, so that's part A. And then part B is now we need to plot this thing on a completely labeled graph. Okay, so let's start off with the graph here. So first of all, let's write a relevant title. So what are we doing here? We're renting a lawnmower. So maybe the title could just be lawnmower rental. That is not how you spell lawn. We're not renting a lamb. Okay, L-A-W-N, lawnmower rental. Okay, now the x-axis. So this is your x, these are your x values, these are your y values. The x value is your manipulated variable. The y value is responding variable. The responding variable depends on the manipulated variable. The cost depends on how long you're actually like renting the lawnmower for. Okay, so the first point is 0, 20. Oh, we got to label the axis first. Okay, so the way to label the axis is, again, it's the name of the variable, then a comma, and then the units in brackets. And if you actually look at the data table, it actually gives it to you in that format right away. So we can just copy that format. So we'd have time, comma t, and the time is in hours. And then we have the cost, it's comma c, and that's in dollars. Okay, yeah, good luck with me writing down this vertically here. Okay, well, let's try this as best as I can. I feel like this is going to be impossible. Okay, so no, do like that. This is easy for you because you can just rotate your page to do it. Okay, so you have cost, C, and then in brackets, you have dollars. Okay, I ain't doing any better than that. Okay. All right, now we need to scale. Okay, so we gotta look at the X scale. Okay, so we gotta take the biggest X value. So let's go back to the table of values. The biggest X value is a 10, okay? Take the biggest X value and divide by the number of squares on the X axis. There's 10 of them again. So this would be 10 divided by 10 is 1, which means every grid line would go up by a 1, but we don't wanna label every grid line. So we're gonna double this to determine how much every second grid line goes up by. So starting at 0 here, every second grid line is going to go up by a 2. So 2, 4, 6, 8, and then 10. Now the Y scale, so let's go back here. What's the biggest Y value? The cost, it's 100. Okay, so let's do 100. Divide by the number of squares on that axis, which is also 10. Again, I'll give you 10 by 10 grids because they're easy to deal with. Okay, so every grid line will go up by a 10, but we don't want to label every grid line, so we're going to double that. So multiply by 2, which means every second grid line is going to go up by 20. So this would be 20, 40, 60, 80, and then up to 100. Okay, now that we've got our titles and our scaling done correctly, now we can plot the points. Okay, so the first point is 0, 20, which just means don't go anywhere left or right, just go straight up to, I'm going to plot it with a different color just so we can actually get it to stand out here. I'll do it in purple. Okay, so 0, 20. So my first point is going to be located here. Okay, the next point is 2, 36. Okay, so we go across by 2 and then up to 36. Okay, so here's 20. 30 would be halfway in between 20 and 40. 36 is going to be a little bit closer to 40, so maybe about like right here. Then we have 4, 52. So we go across by 4, up to 52. Okay, so 50 would be halfway between 60 and 40. So 52 will just be a little bit above that. Maybe about like right here. Okay, and then we have 6, 68. So we go across to 68, across 6, up to 68. So 70 is going to be located here. So we'll go just a touch underneath that to 68. Okay, right here. And we have 8, 84. Go right to 8, up to 84. Okay, halfway between 100 and 80 would be 90. 84 would be a little bit closer here to 80 compared to like 90. And the final point is a freebie. It's just 10, 100. So that actually is going to be at the complete edge of the graph. So across by 10, and then all the way up like this. Okay, and then if it is a linear relation, then we're going to put a straight line through that. Okay, so I'm going to pull a straight line off here. Again, you can now just pull out a ruler and just do it, okay? But I don't have that luxury, so I'm going to insert a shape. So let's get a line in here. Okay, let's change it so I can actually see the line. So let's make it bold. Let's change the color to blue. Okay, and then let's just see if I can get this line to fit through all these points. So I'll get it to start there. And then let's just adjust the slope so it actually fits through. That's pretty good. So then if I just go back to the slide, I can see it a little bit bigger. And that would be a nicely labeled and completed graph. So again, you have a title above, you have title for the X and Y axis, you have the X and Y axis scaled properly, I've plotted the points correctly, and then I've drawn a line through the points to show that it is indeed a linear relation. Okay, so that's it for the end of this lesson. You can practice this by doing, there's going to be 2 questions. So 2 graphs we're going to have to construct in the constructing graphs assignment in the linear relations workbook. And then I'll talk to you in the next lesson.